Alright, hi Year 12s, this is Mr. Lim here again, and this is the first video about rate and yield optimization, and we're going to deal with temperature first up. So, industry is always trying to make the most chemicals in the fastest amount of time, so a maximum amount in the shortest amount of time. The amount of chemical you can make is called the yield. All right, this concept of yield is also the amount that you actually make compared to how much you theoretically could have made, and we'll deal with yield calculations later. But yield can also be a term that's used in general ways to say just how can you maximize the yield, rather than just to say calculate the yield. Okay, so it can be used as qualitative and quantitative sense. And then how fast you produce is called the rate. That's the good English, Mr. Lim. All right. So how fast you produce the stuff is called the rate. And it's really super important to really remember the difference between rate and yield, because sometimes they'll ask you to maximize rate, sometimes they'll ask you to maximize yield, and you have to be able to discuss both of them independently of each other, right? Otherwise, you're going to get stuff mixed up. Okay. The temperature will affect the rate and the yield of a chemical reaction. Yeah, Mr. Lim, you can really English. And optimization of the temperature is important to make lots and lots of money. Right. So temperature and rate. So you'll want to have the fastest rate of reaction, so a high temperature is required. Okay. Why does the high temperature increase the rate of reaction? Well, it increases the average energy of all particles, which hopefully you remember if you're using collision theory, which means you then have to talk about the particles having sufficient energy and colliding more often. And really, it's really about more often, okay? Because remember, everything has to be about rate, and so you have to use some words that relate to time. So more often, more frequently, things like that, not just more, or there are more of them. You have to say it's something per unit time, okay? Thus the rate of successful collision increases, and thus the rate of reaction. Okay, so again, it's not the number of successful collisions, right? It's the rate of successful collisions, or the frequency of successful collisions. All right. Next is temperature and yield. Okay, so when you're trying to maximize the yield, it depends whether the forward reaction is endothermic or exothermic. And we're always talking about the forward reaction because you're making something, so you want to make products of something. Like, even though it's an equilibrium reaction, the one that you want to make is the product, so therefore we talk about forward reactions. Okay? The endothermic is reaction when the temperature is increased, and the exothermic reaction is favored when the temperature is decreased, or high or low temperatures. All right? So this is all, remember, from equilibrium. Remember that the word favored is different to increase or decrease. Favored just means when one reaction rate is higher than the other. Okay, so the endothermic reaction is favored when the temperature is increased, but it doesn't necessarily mean that one reaction went up or one reaction went down. Just remember that when you have a temperature increase, the forward rate of reaction increases. The reverse rate of reaction also increases, just the forward rate of reaction increases more. Okay? And so when you have the opposite, the temperature decreased, okay, if the exothermic reaction is the forward reaction, then the forward rate of reaction will decrease, but so will the reverse rate of reaction. Okay, but if the exothermic reaction is favored and the exothermic reaction is favored, then the rate of reverse reaction will decrease more. Okay, so this is all like equilibrium stuff. There'll eventually be videos on equilibriums that you can look up, but the idea is that you have to remember that temperature will affect both rates of reaction differently, right? And and one of them will be favored, not one will increase and one will decrease, because they'll both increase or decrease. Okay, so that's to maximize yield. If the forward reaction is endothermic, you need a high temperature. If the forward reaction is exothermic, you need a low temperature. Okay, so it's really important that you read the question, because it'll just be like, oh, how do you maximize yield? Sometimes it's going to be you have to lower the temperature to maximize the yield. All right. So therefore, there are situations where you need to compromise. Okay. If the forward reaction is endothermic, a high temperature favors both the rate and the yield, which is good, you know. So when do you stop increasing the temperature? when you're about to blow up the system, okay, so the safety, and whether when it becomes too expensive to maintain the high temperature of the reaction vessel. Okay, so those are your limitations. Safety and cost become the limitations when the forward rate of reaction is endothermic and you're talking about temperature. Okay, if the forward rate of reaction is exothermic, then the compromise of temperature is found, so a compromise between not too high, not too low, is found by running the reaction at different temperatures, conditions, until a favorable mix of high rate and high yield are determined. Okay, so ideally you just want to maximize your rate of production, so you try it at different temperatures and you work out whichever one's the best and be like that one. All right.